In this video, we are going to understand the BJT switching characteristics. From the lab, this is what we can see, the picture of the BJT, and this is the BJTs BC 107, 108, 109, and this is a notch. Nearest one will be 1, 2 and 3, and the nearest one is the emitter. This is one way. By knowing the BJT serial number and its configuration from the data sheet, we can get which one is E, which one is emitter, which one is base, and which one is collector. Another way is that let me draw it. Let me have, this is 1 and this is 2 and this is 3. Suppose 3 pins are out and there is a notch over here. Suppose 3 pins are out. We can take the multimeter here and measure the potential or resistance between these two. If this is NPN, if this is a NPN, obviously when we measure the potential between these two or resistance between these two, we will get R21 is equal to, between these two, let us say R21, we are getting 672 ohm. And suppose we measure between the 2 and 3, R23, we are getting, it is, let us say, 667, that we practically tested in the lab. What we observe is that R21 is a little bit of higher. So R21 is higher means we are this N is here emitter and the middle one is base. The base and emitter resistance is a little bit higher than the base and collector. That means if I have a transistor and I do not know, our data sheet is not available, and we have the 3 pins are coming out of it, then with the help of multimeter we can identify which one is whether it is a NPN transistor or it is a PNP transistor. If it would have a PNP transistor, suppose this would have a PNP transistor, then if from the middle, and if I take in this middle as positive and negative and of the multimeter, I will connect like this, I will not get any reading. Then I have to reverse my multimeter point to plus over here and minus over here. Then I will get some reading like plus and minus over here. Okay, this side is plus minus because it is about NPN, and if it is PNP, we have to connect it, we have to take a multimeter, and if I connect the multimeter in this fashion, so I will get a reading. So with the help of multimeter and by measuring the resistance, we can find which one is the emitter and which one is the collector. So once it is done, so we can see the data sheet also which is available. From the data sheet, it gives a lot of information about the current, collector current, and the collector to emitter voltage, emitter to base voltage. All these informations, what is the maximum voltage, that is specified over here. So what we are going to do is, in the lab, if BJT is available, let us draw the BJT symbol. So this is a BJT symbol and will be used as a common emitter configuration. So this is the emitter point and we are using as a common emitter. So what we are doing is we will connect an emitter over here and a resistance here. this resistance in the lab, what is already there in that is nearly 70.3 kilo ohms, and we have to connect here one supply. This is a variable supply voltage that varies from 0 to 15 volts. It varies from 0 to 15 volt. And at the collector end, we have the collector end. We can collect ammeter over here. This ammeter will measure in milliampere, and then our resistance. This resistance is nearly, what we measure is 900 ohms, and then we can connect a voltage source, which is a variable voltage source that varies from 0 to 15 volts. The current which is measuring in the base end, this is measuring in microamperes, and the current which is measuring in the collector end, this is collector base, it is in milliampere. So how to do the experiment? The first is, the experiment is, we need to find the relation between collector current and the voltage between base and ammeter. That is, here is a collector current. We need to measure what is a collector current and what is the voltage across the base to ammeter. To do this, we will first set the VC. This is the VCC, and the other side will be called as V base to base, like VB, base voltage. So VC we will set first at 10 volt. So once we set the VC at 10 volt, the current here is supposed to flow in the closed circuit. However, this will not be the case. The reason is this transistor is off. To make this transistor on, we have to give the base voltage or increase the base voltage gradually so that some current will flow through it, and when the current will flow from base to ammeter and exceeds this break voltage, the minimum voltage which is required, nearly 0.6 volt between base to ammeter, then this switch will be completely on and the current will flow. That means we will increase the value of VB, and that will leads to increase the value of IB, and then we will see that this base to ammeter voltage is also increasing. And finally what we observe is the collector current is also increasing. But now this base to ammeter voltage, when it increases from 0 to 0.5, the collector current is only 0. And from 0.5 to like 0.7, the small change from between this, or 0.6 to 0.7, there is much more change over in the collector current. Like it will change from 1 to nearly 11 in milliamperes. So that we will see in the readings that we have taken. Here on the right hand side we have taken that. Here we have taken the VB and IB, these two readings, and in the x-axis we plot the base to ammeter voltage. In the y-axis we plot the IC, the collector current. As you see that the base to ammeter voltage in this range, the collector current is 0. And then when this the base voltage is increased here, the base voltage is increased from here the collector current suddenly rises to up to 10 milliamperes. So this value is in milliampere. So you find that this curve is nearly rises to this value. So that is what this is the relation between IC in milliamperes and V base to emitter voltage in volts. This is the what we get. So this is one characteristics. Second one is that is the output output characteristics, and there what we are going to observe is our objective is to get the curve between IC and VC, collector to emitter voltage. So here what we do, IC here first we'll keep this VC is equal to VCC, this equal to 0, and obviously the value of IC is also equal to 0. Now we set the base current, this base current, to 50 microampere. We set the base current to 50 microampere. So how to set? Increase the value of VBB. Increase this value. Obviously, when we increase this value, obviously the base current will increase, and we let us set it to 50 microamperes. We can set it to 100 microamperes or 150 microampere for taking different readings. So let us set to 50 microamperes, that we have done, and gradually increase the value of VCC, and obviously the value of IC will increase, and then the voltage across collector to emitter will also increase. Collector to emitter will also increase. So what we are going to observe is this IC and VC. What we are going to observe is that there is initially there is a small this IC rises quickly, very much quickly, with the VCE with a very small voltage drop, and IC has rise to the rated value, and after that, even though this VCC is increased, this VCE will increase up to 1.1 volt, and we find this IC value nearly constant. So let us see the reading here. This is on the reading on the left hand side. We can find that this is the VCE and the IC value in milliamperes. This is the VC, and the last one here we can see this is nearly 1.1 volts, and the current this side is IC, this is in milliamperes. So now we can see that with this very small up to 0.2, the current has almost rise to a very high value, nearly 12 milliamperes. So up to 0.2, this you can see that from here to up to 0.2, nearly 0.24, the current has already reached to 12 milliamperes. Then it gradually settled down, and even though the value of VC has gone up to 1.13, the collector current is now 14 milliampere. So this is what we have seen, that how the current increases with change in VC. So these two characteristics, the one is IC versus VB, and there is IC versus VC, that has been plotted in the lab and is shown here. So this is what we have learned. One is that how to identify the transistor pin from the data sheet or by using a multimeter and plotting its characteristics curve, the collector current, with change in VCE and collector current with the change in VBE, base to emitter voltage and collector to emitter voltage. So how does it affect the collector current that we have studied? Thank you very much.